Welcome to solverfy.
In this problem, we are given that there is a bridge which is 26 meters above the river. So let's say this is the river here, and the bridge is 26 meters above this, and we have a coin which is thrown in the upward direction at an angle of 38 degrees from the horizontal, and its initial speed is 17 meter per second, and we are required to determine how far from the base of this bridge will this coin land. So of course this is going to follow the curved path, and let's take the distance from the base of the bridge here as x, which is what we need to find. And along with this, we have to also determine the maximum height above the river where this coin reaches. So let's take this maximum height as h, which is also what we need to determine. So we can see that the velocity here is making an angle 38 degree with horizontal. So in this case, let's find out its horizontal component. So that will be 17 cos 38 degrees, which is 13.4 meter per second. And its vertical component of velocity, well, that will be 10.5 meter per second. And now we simply apply this kinematic equation here, knowing that the acceleration in the vertical direction is due to the gravity. So as it goes up, it's retarded. So we will take it as minus 9.8 meter per second square. And there's no acceleration in the horizontal direction. So first, we can compute the time taken for this to reach this point. And for that, we can see that the displacement is 26 meters in the downward direction. So let's just use this equation first, and let's put the values. So we get minus 26 equal to u times t, so that's 10.5 times t plus half a t square, which is minus 4.9 t square. And this implies that 4.9 t square minus 10.5 t minus 26 would be 0. And solving this, we get the value of t as 3.61 seconds approximately. And that's the time taken to reach this point. So now we can simply use the same equation, and let's use the variables in the horizontal direction. So doing that, we will get the displacement in the horizontal direction x as 13.4 times t, because the acceleration in the horizontal direction, that is 0. So when we multiply 13.4 with 3.61, we get the displacement as 48.37 meters approximately. And now to compute the maximum height, let's use the idea that as it reaches the maximum height from the point where it was thrown, its velocity at this maximum height is 0. So for that, let's use this kinematic equation and put the values, and we will get 0 square equal to 10.5 square minus 2 times 9.8 times h. So this implies that h would be equal to the square of 10.5 divided by 2 times 9.8, and this comes out to be 5.625 meters approximately. So we can conclude that the maximum height above the surface of water, that is this 26 meters plus this 5.625, which turns out to be 31.625 meters. And that's the answer.